What's up? Welcome back. In this episode, you're going to see how to solve day 4 of the Advent of Code for 2023. This one's called Scratch Cards, and we're going to learn all about rightward assignment. So today's exercise, we're going to strengthen and focus on building our rightward assignment muscle. Rightward assignment is a new feature of Ruby, a new-ish feature of Ruby, and we're going to try and use that as much as possible just for fun to practice and strengthen and learn more about rightward assignment. In this episode, we made it up through the gondola to another island in the sky. This one is called Island Island. And when we get there, we have to do something with an elf related to scratch cards. Scratch cards are these little things that you get at 7-Eleven or the corner store, and you take a coin and you scratch off and you hope that you won some thing. It's like a gambling type situation. This is our input. In this exercise, we have some set of winning numbers. Those are on the left side of this pipe operator. And then we have our numbers, which are on the right side of the pipe operator. And we want to see how many times our numbers appear in the winning numbers. And for the first number that appears in the winning numbers, we get 1 point. And the second number that appears in the winning numbers, our points double. So every time we have a winning number, our points are going to double. So it's going to be like starting at 0, 1, 2, 4, 8, 16, 32, and so on. In this example above, the numbers 41, 48, 83, 86, and 17, these are the winning numbers. And we have these numbers, and on the right-hand side, 4 of them match the winning numbers, right? So we see 83 is a winning number, and 17 is a winning number, and 48 is a winning number, and 86 is also a winning number. So 83, 86, 17, and 48 are winning in this row. That means that we get 1, 2, 4, 8 points, right? Because every time we have a winning number match, we are doubling the score. What we want to do is go through, figure out how many points there are in total for the input. So let's grab the input. We'll pop open the terminal here and get started. So we'll say input is equal to, ooh, that's a good question. I don't know if we can do rightward assignment with here docs. That would be a fun one to try out. Let's just see p input. Okay, so if we were to change this around, can we do something like this? Does that work? No. Oh, wait, here. We need to print this out. What? That totally works. Okay, that's a freaky looking thing. All right, let's see. All right, so now we're going to have input dot each line. This is going to be our data. Okay, so what am I doing here with this rocket ship operator? This is rightward assignment. Instead of saying input is equal to this here doc value, we're switching it up and we're pointing it the other way. We're rightward assigning the value of input into this. Now, in the case of a here doc, that's super funky because this is happening after the start of the here doc, which makes it look even weirder, but we're just having fun right now. Okay. So now what we want to do is we want to map over each of these cards, and we want to split out the cards so that we have the winning numbers and our numbers, right? There's a couple different ways we can split this up. I think it might make sense to use, again, we can use rightward assignment here. So we can say card.split. And if we just split it on space, what does that give us? Yeah, so if we split it on space, we can break out card and then this number and then a bunch of numbers and then the pipe operator. Yeah, so let's do this. So we're going to use rightward assignment and we're going to destructure the label and then the ID of the card, and then we'll use splat to grab all of the numbers, okay? And this splat operator is going to hold all of this, including the pipe. So if we just print out numbers right now, we're going to see arrays where we have the string values for the numbers, and then we have this pipe operator. What we can do now is we can again use rightward assignment. And what's cool is that because we want to collect everything on the left into an array, and then we want to collect everything on the right to an array, and we want to like just identify or like split on this pipe, what we can do is say star winning and then the pipe operator and then ours or something, right? So then if we just print ours, you'll see 83, 86, 6, 31, 17, etc., etc. So this is our numbers. So by using this pipe operator with rightward assignment, we're pattern matching. We're saying that grab everything up to the point where we match the pipe, and then grab everything after we match the pipe. So that is pretty cool. So if we, and also maybe we print the array of winning and hours like this, so we can see. So now we have these two arrays, which is perfect. And what we can do is we can use the ampersand operator to get the union of those two arrays. So it's like the set union between the two arrays. So now we can see 48, 83, 86, 17. That is the values that are in the right side that match the values that are in the left side. And what this tells us is how many matches there are. So if we grab off the size and we store that into, oh, we got to use rightward assignment again. All right, let's say this is like the matches, or like the match count or something, right? In order to find the points that we get for the match count, what we want to do is, if you look at the pattern, like 1, 2, 4, 8, 16, those are really familiar numbers because those are the values you get in binary if you toggle on the furthest bit. So there's probably something super fancy we could do with binary here, but what I wanted to do is just say, if the match count is greater than 0, then we're going to return match count or 2 raised to the match count minus 1, right? Otherwise, we're going to return 0. And this is going to give us some result. I guess we could use the rightward assignment again here. So scores, and then we'll p scores. It's just to see what we get back. All right, so 8, 2, 2, 1. And then if we get the sum of those, now we get 13, which was the example input. Okay, awesome. So now let's grab our puzzle input, and we'll drop this as always here at the end. And now we're going to switch from using, so now we need to do data.readLines is data, and we'll run this again. And 15205, is that our number for part 1? 15205, boom! That is the puzzle answer for part 1. A lot of rightward assignment. So you probably aren't going to see much Ruby looking like this if you're looking around, because not many folks are using rightward assignment yet, but this is a good opportunity. Using this advent of code is an awesome opportunity to learn about different features of the languages that you're using. And if you line them up like this, gosh, it almost looks Haskell-y or something. Haskell-y or Rascal-y, I don't know, hard to say, but rightward assignment, hey, it's pretty interesting. Okay. Oh, and here we have a warning that says we have label is assigned, but it's unused. So what we can do is, if we're not actually using label, we can put underscore. Same thing with ID. So we can actually just make those underscores, and that says just ignore the one that's in this place, and we still get 15205 as our answer. This is looking pretty sweet. Let's move on to part 2. Just as you're about to report your findings to the elf, one of you realizes that the rules have actually been printed on the back of every card this whole time. So there's no such thing as points. Instead, scratch cards only cause you to win more scratch cards. If you've been to 7-Eleven or one of these corner stores and you've bought a scratch card, you know that a lot of times when you scratch off the card, the winning thing is other cards. That is the thing that you win. And so in this case, this is a play on that. So we're going to win copies of the scratch cards that are below the winning card, equal to the number of matches. So if card 10 is going to have 5 matches, then you're going to win copies of 11, 12, 13, and 15. So in this example, card 1 has 4 matching numbers, right? We already saw that. And that means that we need to make a copy of cards 2, 3, 4, and 5. The original card 2 has 2 matching numbers. So when we go to actually process 2, we're going to win 1 copy of 3 and 4 from the original card 2, and we're also going to win a copy of 3 and 4 from the copy of card 2. So this kind of complicates our loop a little bit. And so rather than just winning 4 matches here, we need to win 4 matches and then duplicate the 4 cards below us and keep track. And so that's what we're going to do. So once all of the originals and the copies have been processed, you end up with 1 instance of card 1, 2 of card 2, 4 of card 3, and so on. So we're going to process all the original scratch cards until no more are 1. And then our answer for part 2 is how many total scratch cards we end up with. So it's going to be like this cascading thing, right? Where we start at the top and then it falls down and we're going to make more and more as we go. All right, so we have our match count, and we also need to somehow keep track of how many cards we have. Because we also now need to know the ID of our current cards so that we can apply it to the next card below us, I think we actually do want to use this ID number. So we're going to comment out our real data, and let's grab the ID. And the ID itself isn't going to work just as it is, because if we look at it, if we print the ID here, the ID has a colon in it. And so what we want is the numeric ID so that we can work with that card number and like future card numbers, because we're going to want to like increment forward. So let's say that, again, using rightward assignment, ID.2i is now ID. So now if we print out ID down here, we should get back these numbers, 1, 2, 3, 4, 5, 6. Great. Okay, I'm going to comment out scores for now. But so now that we have the IDs, we need to figure out how to make duplicates as we're working through this. And in order to keep track of those, I think we want some counter. And the way we're going to do this is with a hash.new of HK. And this default dictionary, the way that we're initializing this, we're passing in a block. The block passed to new will be executed every time we encounter a new key into this counter hash. And rather than setting it to 0, we want to set it to 1 because we have at least 1 copy of all the cards. So this counter is really going to give us like the number of each card counts, right? And this is going to be like an index of the ID points at the count of that card or whatever, like the number of times we have that. It's like number of copies of that card. Okay. And then at the end, what we're going to do is we'll return the values of these counts. I think what we want to do is, as we're iterating through and we have our match count, we need to do something like match count.times do I, and then that's going to let us know how many cards down we need to go. So we're going to go like card counts at ID plus I plus 1, right? So ID or I is going to start at 0. So if we're on card 1, this is going to iterate to card 2, then card 3, then card 4, then card 5. And every time we encounter one of these, we want to increment the count at that location by 1, right? And that should give us, if we were just doing 1 copy at a time, that would give us that 1 copy for the original. But because we also need to apply it to future cards based on the copies of the current card, we need to go through card counts of ID.times. So for the first card, we'll go 1 time. And then for the second card, it should have 2 in here. So then this is going to go twice. And we actually don't need a counter for that. Okay, I think, I don't know, let's just see what we get for card counts at the end here. P card counts. All right, so we have 1 of 1, 2, 2, 4 card 3s, 8 card 4s, 14 card 5s, and 1 card 6. And I think that's actually what we expect here. 1, 2, 4, 8, 14, 1. 1, 2, 4, 8, 14, 1. Okay, so now what we want to do is I think we just need to add up values.sum. And we get 30, and 30 matches the number of scratch cards in the demo. So then if we just re-enable the actual stuff here, 618, 9740, 618, 9740. Boom. That is the answer for part 2. Awesome. Okay. how could we clean this up? If you've got a keen eye, you are noticing that this is a leftward assignment. This is the same as saying card counts plus equals 1 the other way. I don't actually know if we can do card counts at ID plus 1 plus I plus 1 into card counts like this. Will this work? I don't think this works. Yeah, because the right-hand side, this is not a variable. This is like indexing into a hash. I'm not sure that's even possible. I don't know. Maybe we would need to do some other thing for this one. I don't know. If someone else knows that answer, let me know. I think we'll probably have to just call card counts.set or some other method. Yeah, instead of rightward assignment. Obviously, we're like calling methods all over the place here, like .size, .2y, .map, etc., etc. But yeah, I don't know. I think it's neat. So yeah, that was fun. Cool. Perhaps in a future episode, we will talk about how we might have done this with some bit fiddling, because I think you could do something like a match count, like some sort of like shifting, right? Like we want to do 1 or 0, 1, shift match count some number of times to get us back that number. But for now, I think this is pretty sweet and I'm happy with it. Thank you so much for watching. If you are enjoying this series, please don't forget to subscribe and we'll see you in the next one. Cheers.